So welcome everyone. This is the Fireside chat on performance evaluation frameworks for autonomy. This is the second event in our series. The first one we did almost about a month back was on machine learning data strategy for autonomous vehicles. So this is our second event in the series where we'll keep talking about the importance and the value of data and how we harness the power of data to solve, autonomy problems around autonomous systems. So today we have with us a couple of my very esteemed colleagues from my previous experiences, Nick Horsborn and Melinda Korbor Kale. So they are joining us from different locations. So Nick and I, we worked at Aurora before in my previous life, and then Melinda and I recently worked at Motional, where they both are coming from. So how about we get some introductions out of our way and then, jump into the topic. So if I first may ask Melinda to go and then followed by that, Nick, and then
Absolutely.
we can come back.
Yeah, thanks so much, Sahil. Really excited to be here and talk about this very important topic. So hi, everyone. Like Sahil said, I'm Melinda Kale. I'm currently a senior autonomy engineer at Motional. Motional, if anybody doesn't know, is a robotaxi startup based in Boston, and we have operational sites in both Las Vegas and Pittsburgh. Currently, I'm working with our perception team to improve our onboard detection models that run on our vehicles. But I've also spent quite a bit of time at Motional doing end-to-end autonomy system performance evaluation, working to determine both the right metrics to use, and then also leading a team of engineers to actually implement the software and data frameworks that were needed to produce those metrics at scale. And prior to Motional, I was at another AV startup called May Mobility, where I worked as a robotics engineer across many different disciplines, perception, behavior, and again, actually performance analysis. So it's a little bit about me. Excited to be here.
Thanks, Melinda. Nick?
All right. Hey, everybody. My name is Nick Orsborn, representing Aurora Innovation. For those that may not be familiar, we're actually just a couple months out from launching our first product, which is long haul trucking in Texas between Dallas and Houston. I'm based in Pittsburgh. Aurora has offices across the United States. So actually, my career started in the energy sector, where I spent 8 years as an operations geologist. And I'm assuming most people on here are like, wait, what? But for the past 9 years, I've been immersed in the world of autonomous vehicles, working across labeling for perception and motion planning, vehicle operations and mapping. For the past 4.5 years or so, I've been focused on autonomy triage and performance evaluation, helping to refine how we interpret, navigate, and respond to the world. So excited to be here today, share some insights from the journey and discuss some of what we've learned over the past few years.
Awesome. Good stuff. I was definitely one of the individuals who didn't know that Nick was in the energy sector before. So that was a news to me as well. And, when we connected on this particular agenda. So good stuff. So a couple of logistical things. If you have any Q&A, please drop them in the Q&A section of the Zoom, and then we'll take them towards the end of this discussion. So the format of this conversation is going to be a fireside chat. Essentially, myself, Melinda, and Nick, we're going to have a chat as if you're all just watching us talk virtually, and we'll just take questions towards the end. Now, unless there is a question which we find super interesting and in the flow of the conversation, then I know I can pick and choose in between. But keep dropping your questions, and as you hear us talk more about the agenda, we'll tee those questions up towards the end. Awesome. So the topic we have, right, is performance evaluation, and Nick and Melinda and myself, we have a lot of shared as well as individual experience in using the data for evaluating and benchmarking our autonomous systems end to end, specifically autonomous vehicles, including robotaxis and trucks and so on. So maybe one of the first, just kind of easing us into the conversation, right? We talk about autonomy product development, right? All the way from your understanding the business use case to building a solid technology and a product to meet that use case. So starting with perhaps Nick, from you, where do we see the role of performance evaluation and data in autonomy product development? Like, where does it fit into the sort of traditional product lifecycle? If you want to start first.
Yeah, of course, of course. So, yeah, I think at a high level, I think feedback data plays an absolute crucial role in the product development. I think the key thing I've been thinking about in prep for this conversation is just the continuous improvement, being a really important part of that, and system reliability, helping to get the system to be reliable and of course safe. So. I think just very generally speaking, helping to identify performance gaps, refine the system, ensure that the product ultimately meets the real world demands. Um, yeah, I mean, I think I'm happy to talk a little bit about some of the traps that you can fall into as well. But yeah, that's from a high level.
Okay. So performance evaluation and there are a bunch of these other what we traditionally call flywheels, right? Because they're like your continuous improvement iteration loops. You get the output, you get the data, you process that data, you use that to kind of feedback into your system, and then overall improve the sort of performance of your end-to-end product over a period of time. So Melinda, what's your experience on that? Like, what have you seen some of the data flywheels work better than the others? Where do you see this again, performance evaluation analysis fitting into the product lifecycle?
Yeah, yeah. Definitely seeing different versions of it. And I think a common theme of kind of where a lot of the work and effort goes to make it effective has really been on kind of obviously using the vast amounts of data that we're all collecting and labeling and triaging, actually using that, to get the most useful signal. And I think a lot of effort has gone into really refining what we need from that signal, because it needs to map really tightly between, obviously what a user would actually experience if they were riding in an AV or trekking, what the actual experience would be. It needs to map really tightly to like a numerical metric, right? That when it goes up, that means something is good, and when it goes down, that means something is regressed. But it has to be robust to kind of environmental factors. If we're thinking about on-road data, it has to be robust to simulation artifacts and things. And so that's where I think a lot of the work has gone. It's also where a lot of the trap kind of that Nick was talking about. There's tons of data, and I think that it's really about how you actually make use of that data. And I think that the problem I've seen too much is just too much data or an ineffective use of it to really map to what are the highest, the impact issues that we can address.
Right, and I think that opens up another, sort of an orthogonal point that we all say that more data is better, which is true in most of the times, right? Like more data you get, assuming that the utility of the data and what you do with it is proportionately getting better with the volume of the data. But speaking about some inefficiencies, right? Like when you have larger data sets for evaluating performance, along with not having very objective metrics, what are some of the other inefficiencies, Melinda, that you've seen where we have the data, we have the process, but we're just not able to make sense of that data? Like, can you talk to us a little bit about those inefficiencies, maybe one example or two examples?
Yeah, I think it's really easy. There's it's easier to be inefficient with your data than to be efficient. And I think some examples of things that I think I've seen across the board are really not having that really tight connection with the in-vehicle experience. So I think time and time again, I've seen, certainly in my career, the easiest way to get a real true signal of maybe what the biggest issue is with your autonomy system is for, me or one of my colleagues to just go sit in the car. And of course, that is just not scalable, right? We can't do that outside of a, research lab kind of environment. And so we have to find ways to really extrapolate that experience that we really care about and distill that into data. And so finding the ways, like the highest correlating factors of whatever data, like the massive amounts of data that we do collect, and actually pinpointing, which signals from all of that data map the closest to what I'm actually experiencing in the car, so that we don't have to rely on, engineers' butts in seats kind of experiments.
Yeah, very true. I mean, if you can get everyone, just be in the car and get, feedback from the road and the field, I mean, that would be the most ideal, because you're almost, getting first-hand experience of whether you're in a truck or in a car or which autonomous system, right, you're talking about. A couple of things I think, for the broader stratification of the problem here, right? The data that we talk about is the overall data that you get from your from your platform, right? That could be your sensor data, that could be your telemetry data, that could be anything that is logged and captured on board for input into the performance evaluation pipeline. Now, the output of that could be a metric. Output of that could be a very detailed root cause analysis sort of classification of your problem. And then that further goes into creation of your simulations, creation of your other test cases, structured, unstructured, for system, subsystem, component level analysis. So I think that is the maybe that's the background we want to make sure people understand of our conversation. And a good segue, Nick, for you. I mean, you have been doing this, almost as much as we have worked together before. What are the sort of skills that you look for, right? When someone wants to be a part of this function and team, is it a traditional systems engineering knowledge that you need, or do you need something more niche, bespoke to be a kind of an expert in doing data analysis for autonomous vehicles?
Yeah, absolutely. I think that's a great question. I would say for my organization in particular, I would say we have a pretty diverse set of skills and backgrounds. I mean, coming from a geologist, I think for me, some of what I look for are people with varying scientific backgrounds, right? So maybe they don't have a background in robotics or a background in performance evaluation necessarily, but they've got critical thinking skills that they've developed through their education or direct experience working in sort of a science-based field. Now, I think I'm sure we'll talk a little bit more about scale and and other development in a bit, but I think an important part is if you want to start really digging into your data, you are absolutely going to need some people who have data science or data analytics background. So some of this, pure skill sets, I guess, for a few people on my team, skill writing some code in Python or working with R, SQL, for example, right? So some of the data analysts on my team who are crucial to actually, sort of taking the data that the rest of my team is creating and putting it in a way that, putting it in dashboards or manipulate it in such a way that it's usable for our partners, internal partners, external partners. They rely heavily on their technical skills from that perspective. Now, certainly in an organization too, depending on how your org's actually set up, you may, like you mentioned, also need some systems engineering folks as well. The way that Aurora is set up is that we actually have a separate systems engineering and test engineering org. But yeah.
Makes sense. I mean, one of the individuals I've worked in the past for Triage, she was a graphic designer and she was one of the best, right? So nothing to do with robotics, with autonomous vehicles, but the creativity and sort of hierarchical problem solving from the initial symptom to the diagnosis to the end root cause and even corrective action sometimes. I mean, I'm surprised by the sort of teams I've led in the past where someone who has no experience in actually autonomy engineering, they have recommended solutions, which then you have engineers who can go and implement that in their ML models. So it's pretty diverse, and we'll continue to talk about how these different skill sets sort of fit into one another. So Nick, a follow-up for you, right? I mean, we talked about the introductions to autonomy product development and where does performance evaluation fit in. What is a sign of a good, healthy data analysis performance evaluation pipeline? If you had to build the world class, which I'm sure you already built that at Aurora, but if you had to kind of reinvent the wheel and sort of have it ideal, what are some of the components you consider as an anatomy of a good performance evaluation pipeline?
Yeah, for sure. I mean, admittedly, we're always working on it. Nobody's perfect, so it's definitely like an iterative process, I think, is one of the key things. But I guess if I had to kind of break it down in a few layers, I think first and foremost is really about the data acquisition and signal capture. So we talked a lot about how you want a lot of data, right? But if you're going to get inundated or drowned out by that, then I think that's obviously a problem. So I think you need diverse inputs. So, the majority of my team actually works on simulation test review, right? And defect burn down for the simulated environment. I think that's super important because it's impossible to drive every possible scenario that you may encounter within an operational domain. There's so many uncertainties and factors. So it's really important to have a robust and reliable simulation environment. My team personally doesn't work on hardware in the loop or hill type, but I think that's another important signal as we think about like the integration of our software and hardware. So that's another important part. And then real world data, certainly you can't beat it. I think for us, there's a couple different types of real world data that's important to collect. So manual data collections where we can learn from our expert drivers, maybe what to do in different scenarios. And then that also is feeding into a lot of our labeling, perception labeling pipelines and whatnot. I guess moving on to the other two, processing the data, the differentiation and analysis. So, we really need to filter the signal. Because you can get inundated with the data, you really need to prioritize what you internally are going to define as high impact. Now, on the surface, that might immediately be safety critical or highest severity. But as you start to get closer and closer to launching a product, or once you have an actual product on the road, certainly you're going to hope, okay, we don't have safety critical issues anymore. And now you're starting to refine is like, what is a high impact from a product standpoint? What are our partners for Aurora? That might be, FedEx or Werner or Hirschbach, or maybe even Volvo. What are they going to care about as their product, as part of our partnership, is out there in the real world on the road? What are they going to care about, right? For their own brand, for their safety and their own product, right? So you need to prioritize high impact events, and I think that is important to make sure that your internal partners are all aligned on that. We talked a little bit about metrics and benchmarking. I think one key point I want to make here is that you, in my opinion, and this is a lesson that we've learned from Aurora, is that you really need to compare against expected performance. I think one issue that we ran into years ago is that we were evaluating on an absolute sense versus what our system was designed to do, or what the expected performance was. And so it's really important that you compare against what is expected. I can go into some detail there or share some examples later if you'd like. And then finally, actionable insights and feedback. We talked about the loop, and we're all going to just keep saying the loop because it's so important that it really is a flywheel, and that we're constantly iterating. It's important to decide who's getting the data, how we prioritize that, and then how we integrate it into training data, software updates for future development.
Very well said. I think that's basically summing up your development life cycle, from end to end. And I think one equation sort of, that sits in my head all the time is essentially a dot product between your, frequency of exposure, severity of the event, relevance of that event to your product development. Because look, at the end of the day, we're always going to have these, 5%, 10% of the events which happen, extremely rarely. But when they happen, they're basically like finding like striking a gem in the mine, and then you sort of capitalize on that. Well said in terms of importance to your milestones, and how does that actually feed into the end commercialization of the technology that we talk about. Melinda, your perspectives on this, maybe if you can share an example where a good and bad both, right? Where we found a great example where, hey, if this was not for the pipeline or the performance evaluation sort of ecosystem we had built, we would have never been able to find. And something that we found, but was of a much lesser value and was more of a noise that led the team to go into a goose chase, and we ended up nowhere, but just sort of a dead end. Will you just elaborate on that?
Yeah, definitely. And I think thinking about the examples that I've seen, and how they kind of apply to what would a very healthy, or like what's the gold standard that we're striving to, something that we're always trying to do at Motional, and certainly I think across the industry at all the organizations I've been at, certainly, is how do we push more and more testing further to the left? Meaning, how do we get more testing closer to the actual developmental changes? What tools can we have to kind of incrementally build the signal that we're getting? And really to do it cheaper and faster than what we've been able to do, right? We talked a little bit earlier about maybe the easiest or the best, the simplest way to get feedback is, on-road driving, right? That's kind of straightforward. And even that comes with all of its own challenges. But of course, that's the most expensive, the most labor intensive, and the most, risk when you're thinking about testing. Of course, you want to eliminate as much risk as possible by doing testing earlier in simulation, like Nick pointed out. With hill testing, we can really do a lot before any code, actually makes it onto the vehicle. And we should, and we kind of have an obligation to do that and continue to improve those systems. And I think that to your original question, Sahil, of examples of where we've seen it, I think those are some of the proudest moments, is when we've actually been able to catch, potentially problematic issues, earlier in the test pipeline. We didn't need it to go onto a vehicle. We're able to catch it in simulation, in hill testing, even close course testing, right? Things that you're able to see earlier in the testing pipeline, I think, are some of the most impactful. And as you can, every time you catch one, you might do a post-mortem and figure out, how could we have caught this even earlier, right? What steps could we fit into our, every time a developer pushes a piece of code to the cloud, can we run, CI tests? Can we catch something really, earlier, so that we don't even have to get to the point where it got to?
Makes sense. I mean, at the end of the day, we also, to your like moving to the left, right? The goal that we all have is to minimize any surprises, right? Things that we don't expect, right? I mean, if we have deficiencies in the system, we have failures that we're aware of, and finding that ahead of your driverless deployment, I mean, that's fairly good. I mean, that's essentially validating the hypothesis that the things that you knew ahead of time, you're kind of seeing it from the real-time data. In fact, I remember quite a few situations where you and I worked on. We had things that we found in the field, and we were like, hey, what can we do to move this up left in the chain? And we found gaps and holes in the processes and in the tooling and in the teams that we have. Then we later on fix them, and then over a period of time, that 50%, 60% becomes a long tail of 90%, and then you have a few specific types of cases that you got to solve in the last 5-10%. Which, by the way, becomes like, I don't want to underappreciate that last 10%, because that becomes the difference between launch, go, and no go, because ultimately you need to be extremely confident on where you are in your whole system, when you do launch, like your team is going to prepare for in the coming months. So, which takes us to the next segment of this discussion about safety criticality of the work. And Melinda, since I have you here, right, we use these terms, and I think probably more traditional automotive, where we have very defined verification validation cycles of having a product, having a software out, and then it goes to the full V&V cycle. We lock in the changes, and that kind of goes out through the V&V process before deployment. I believe for autonomous vehicles, I think the backbone is very similar. I think we are all kind of using the similar standard systems engineering, VM, kind of following that. But I also believe that there are different flavors by which we do this, achieve the same goals, maybe by different variations of that process. So how do you see this triage and performance evaluation analysis that kind of goes in? Is it a part of the same V&V model that we do as an industry, or that's more of a unstructured input that goes into a more formal structured V&V output?
Yeah, it's a really good question. I think it's still something, I think, that's under development. I don't think anybody's quite figured out exactly the right way to do it. I think there's lots of really good progress out there from many companies that are obviously have launched commercial, fully driverless solutions, are doing it safely. And so, I think it becomes really important to think about the kind of implications of the metrics and insights that we are getting from data, and like how those are going to be used to make decisions that are safety critical. And when it comes to kind of, traditional V&V or kind of acceptance testing, in my view, I think it's just really important to make sure what question you're really trying to answer. Are you trying to, there's a big difference between, is this AV product ready to go driverless in a new geographic location, or versus like, did this new model release improve our handling of crosswalk pedestrians? And so the types of information and the types of processes that you're going to do to answer those two different questions is probably going to be different. And I think appropriately so, right? And when you can reduce, when you can reduce risk by, for developmental testing, having a safety driver behind the wheel, when you can reduce risk in that way, I think it can be really appropriate to look at very different metrics and very different pieces of data to kind of make the determination to answer that question, versus when you're in a, when you're trying to answer the big question of, are we ready to launch this product? And it really just comes down to like knowing what question you are trying to answer, and then how we funnel our data and insights into that.
Right. I think you mentioned an important word there, right? The risk tolerance, and I think the quantification of the risk and sort of putting that into a risk framework, right? It's different for different companies, and I think it has to be, right? Because this is not a autonomy and autonomous vehicles is a technology we're developing, we're evolving, every single day. Now there are some more common benchmarks, that we have compared to, what we used to have like 10 years back, right? Before then, it was all about, okay, go and try and see what sticks, and if it doesn't stick, try to do something different. Now that definitely has changed, but importantly, the framework and how we do it is still very different for different companies, depending on their phases of where they are in the overall commercial launch. Nick, any commentary on from your end? I mean, you're kind of getting close to commercial launch. Anything that you can share in the public forum? Of course, if it's internal, let's not.
Yeah, of course. Yeah. I'll keep some things tight-lipped, but I can definitely speak more generally. I guess just to kind of reiterate what Melinda mentioned. I mean, I think performance evaluation is inherently safety critical, as it really is sort of like the first line of defense in identifying failures. I think. I certainly think that performance evaluation and the formal V&V process go hand in hand, because performance evaluation feeds into that formal V&V. But I do think they, serve some distinct roles for autonomy development. I think inherently you want your evaluation to be fast and iterative, right? Where V&V, I think, provides a more formal rigor before deployment or leading up to your deployment, and certainly after, right? Because I think the performance evaluation itself is meant to identify those key failure modes. So you've got some perception blind spots, or you've got, over braking, under braking, something, that's kind of happening. Those insights from the evaluation then go to refine your validation and your coverage for your test set. So because I'm in Pittsburgh and it's foggy a lot, I'll just use an example, but if you find some failures that or deficiencies around foggy conditions, your first thing should, you use that data to say, okay, well, do we have any fog specific test scenarios? What does that coverage look like? Do we expect it to perform well? And if so, then that we would consider that a test escape. Something's off there. If we don't expect it to perform well, we might ask ourselves, well, for like the V&V process, do we have a coverage gap? Do we need to build more tests? Whether that's on a test track or in a simulated environment, or do we need to go manually drive in anytime there's fog to collect some more data? So I think that's a crucial part of it, is being really in tune with your coverage from that perspective. And then, you're going to continue to formally test the system against that before you deploy. And then certainly sort of back to that cycle and flywheel, is that, if you find that there are failures in your V&V, or you do have a coverage gap, once you have those tests created, then it's back to the performance evaluation of these new tests and how they fit in with the overall coverage. So, so yeah.
Okay. Yeah. I think they all kind of, your structured systems engineering, V&V, and your performance analysis. And performance analysis, I think, is a more general term. We can use it for even when you do your systems V&V, right? I mean, they're kind of all feeding out and feeding into one another. So quite a lot of overlap between these different sections. All right. So I think so moving on to the next topic, right? So I think we talked about the safety critical nature of this problem, and I mean, they're all every bit, Nick, that you especially talked in the workflow has been important in making sure this pipeline is healthy and good to go. One thing that we often hear from our leadership and management, and when we kind of do this work, is how can we find and evaluate things faster, right? Like, okay, if you take your car out and or take a platform out and go and run and you get the data out of it. You spend some time, the data gets ingested, you review it, and then you're like, hey, there's a perception problem. Okay, great, but we had the problem. Okay, how could we have prevented that from happening before? And I'm not necessarily talking about. I think we mentioned some of the stuff here about moving to the left, using simulations and offline testing. Excellent, right? That's how we can stress test. That's where we can get millions of exposure data from the platform. But is there any way in which we can do sort of predictive modeling to say that, look, this is the state of our system. We know that these are the kind of problems we've had before. What inputs we can put into some sort of modeling this behavior so that when we know that we land these changes right on your main line, what is the performance of your system going to be? So a little bit of like crystal balling out the change, its impact, and how we can improve the performance. Either of you, Melinda, if you want to go first, or Nick, like what has happened in this field so that there is more data science-y, predictive analysis for performance?
I'm happy to jump in. Yeah, certainly at Motional, at my time at Mobility, this was the name of the game. How do we do exactly what you've suggested here? How can we kind of predict either places we expect there to be failures or gaps in our system? And also kind of the inverse almost of, if we do make this change, what do we actually expect the impact on top line performance metrics to be? That's a really powerful thing to be able to do. And of course, that's like you mentioned, leadership at Motional, I'm sure at all companies, that's what they really want to know, right? What changes are we making, and what do we actually expect the outcome to be? And so that's certainly something, lots of people at Motional are working very hard on kind of answering and improving the way that we do try to answer that question and predict that outcome. And we do it by leveraging a lot of the historical data that we have collected, kind of analysis and kind of generalization of our system performance into kind of the capability space. So thinking about, kind of key capabilities when we're thinking about what types of scenarios and situations does an AV need to interact with, and what does our test coverage look like? What does our, system performance look like across those? And then kind of combining those and correlating those, using various different, predictive modeling techniques to then try to answer the questions, everything, right? What's the impact on top line performance metrics going to be? Where should we expand our testing, both in simulation and on road, so that we can, actually expose our system to more of the problems, the things that we need to do, and all sorts of different things. Really trying to predict that is kind of where we're going next. And I think there's
that's a hard problem.
Oh, absolutely. Right. Yeah, I mean, there's teams of people at Motional kind of just working on this, all completely offline, right? None of this is the predictive decision-making tools that we use online. This is all, using offline data and trying to answer that about our system.
Right. I think the statistical, your ICA, PCA, kind of, putting your different variables together and kind of figuring out. It's a very interesting, like a field in itself, right? When you have a bunch of data points and you're kind of predicting what would be the output of a change on top of, certain state of your system, becomes very interesting. I do want to double click, Nick, but before I go there, any thoughts on this like predictive modeling using data?
Yeah, I definitely think this is the way that we all have to go. I guess just a couple comments. I think a couple of other things just to add on to what Melinda said is that, yeah, I think that within like autonomy groups, I see this maybe within certain subsystems. So certainly perception for their own use case is like, actively trying to build things to be able to identify, sort of trends or known issues and not be in a reactive state, but kind of predict how performance will be. Certainly, motion planning system might behave in that way. I think one of the tricky parts is how you move that online, as Melinda said. It's like a really difficult thing. I think in a perfect world, like the system would just be like, oh, I know I'm bad here, and I'm just going to get better. I'm going to learn from that. And I think we're a ways off from that. But I think the point that we're after here is that, retroactive data analysis is valuable, but it's slow. And it might be the right thing to do as we, at a smaller scale. But as you start to really scale your fleets, the number of vehicles on the road, whether it's through ride sharing or trucking, you really have to get to start to work in like a very data-driven way to figure out like where are our weak points, what are the things that we maybe don't know yet, how do we deal with that uncertainty. I think through the simulations, can we go ahead and proactively generate some of these edge cases that maybe we've never seen, but we anticipate might happen? I think that's a really important part of simulation, is saying, hey, we've got this whole set of thousands of variations of the same exact intersection setup, and like we can use the past performance to help figure out and simulate what the future possible risks are. So yeah, I know, like Melinda said, Aurora also has a very large data science team, both and also a lot of our subsystem teams are kind of working on this for their use cases as well.
Yeah, no, very cool. When I used to be with Aurora, right, we used to work on a bunch of these data science problems, and I'm sure the scale and the nature of these problems has evolved in the last so many years. I think taking a step back, right, the maturity of your system as a curve, and complexity of the problems as another curve, right? I think they're kind of inversely proportional to each other, unless we are doing something really wrong in that setup, right? As you kind of build your system towards a launch and product becomes more mature, the kind of problems that you're going to get are hopefully getting more predictable in a way, but they are also, kind of a little bit unexpected, because if they're expected, you might as well have solved them, before. Right. So the volume of these problems and the complexity, I think that equation changes drastically as you're kind of getting close to a, sort of a product ready for a, launch. And I think the important thing which you both mentioned, and I want to double click on, is the test coverage and ODD analysis in a way, right? I mean, operational design domain, for those of you who are not completely aware, that's basically setting the constraints of your environmental operations, from the infrastructure to weather to your capabilities to whether you can do a traffic light, roundabout, left turn, right turn, all the different sort of, things that you can imagine, right? That basically becomes a founding framework to understand, where we're going to launch or where we're going to even drive before the launch, and then, prepare for the launch, in terms of perfecting those capabilities. Belinda, maybe from your end, like this whole understanding where you currently drive and your performance in a given ODD, in your opinion, doesn't necessarily need to be emotional, but like in your opinion, how do we use this to inform where else we can drive based on your current driving ODD?
Yeah, absolutely. Yeah, I think a really important thing that you've touched on is kind of this idea of capabilities and ODD, and having a clear understanding of your system's performance in the different categories that you expect it to operate in, and then kind of pairing that with when you are thinking about expanding to a new location or expanding within an existing location on new kind of capabilities. Maybe you're going to, like you said, start doing roundabouts where you've only done traffic lights before. It's kind of being able to map expected behavior based on historical context, and of course all the simulation that we can do without necessarily putting our autonomous system in a new place, comparing that with the actual ODD analysis. And so when you can do manual data collection and then analyze it in the exact same way that you would autonomous data, you can actually break that down and see how it would perform, right? How similar is this new ODD or this new place that you want to go to compared to what you are able to drive, and kind of match your level set the expectations of the system. And like we point out here, then also immediately start thinking about actually expanding test coverage before we even think about driving there. Is we should be doing this in simulation with hill, with all sorts of different non public road driving before we even get there and really start evaluating it.
Yeah, right. Yeah, I mean, every, for example, intersection, even though it's the same with the traffic light and sort of two lanes each direction, looks same, but there are different traffic patterns and different sort of subcategories of that intersection handling, which could be different, for example, in Las Vegas, compared to somewhere in Texas, right? For example, or maybe somewhere on the East Coast like Boston or New York, right? Like the driving patterns change, right? And you also want to make sure you're not overfitting your system to one place. And maybe sometimes you are, because you're like, look, that's going to be my ODD for the next 5 years, and I don't care where we are in the next 10 years, but I want to make sure my performance is going to meet, the expectations of this very specific, focused ODD. Although a lot of times that's not the strategy that, you don't want to go so much overfitting on one performance that it's going to take you another 10 years to build, from one ODD to the next ODD. Nick, any thoughts on this expansion approach? Sort of using the transferability of your performance and kind of predicting where else you can drive.
Yeah. Yeah, absolutely. I guess one thing I wanted to comment on too that maybe we haven't touched on a whole lot, and I mean, we have whole teams that focus on this, but I think, designing a system that that sort of can respond to uncertainty, I think is an important part. Like, recognizing that we might be out of ODD or we might be in off nominal conditions is super important, right? So because I think you can try to predict and you can try to define this box that is your operational domain as best you can, and you do a ton of work to do that. But ultimately, like, what we see is, oh, this unusual construction pops up, on this ODD, and or suddenly this weather system comes through that is absolutely out of ODD. So how can you design a system so that it recognizes that and responds accordingly, which oftentimes is pulling over to a safe location, whether that be the side of the road or, safe harbor spot or something. So I think that's something that's absolutely fundamental before you start to expand your ODD, is being able to have that fault management system or off nominal triggers that allow you to pull over safely should something come up. But in terms of the transferability, I think that's something that we, for the Aurora driver, that we tout a lot. And I mean, this is public information. Is our first product's going to be between Dallas and Houston. We've been actively operating between Dallas and El Paso, heading west. I think sometime in Q3 or Q4 last year, we actually did sort of a transferability test all the way to Phoenix, and with vehicle operators. Of course, we did a lot of offline testing before, tons of analysis on any deltas in that ODD, and
Right.
And I think that was like really helpful to be able to go and experience that and see, like, are we actually able to do this? Are we actually able to go operate in other lanes? Now, granted, this was daytime, nice weather conditions, as maybe you'd expect, maybe a little hot, but as you expect in Arizona. But but it was kind of a nice way to actually go and drive that and experience that. But I think, back to having that coverage, understanding your ODD, understanding what to expect, is a really important part. You basically have to do a lot of due diligence beforehand, but you should be able to trust that all of that work that you put in for previous ODDs should transfer
Right.
over.
No, very well said. I mean, especially construction, that has been our, sort of a bone to pick with in around Las Vegas areas, right? You see the construction coming in and out, like pretty much, unexpected, right? I mean, and the types of the construction you see from an experience has been, pretty drastic, right? So the point being, the uncertainty handling and having a sort of a probability curve of what situations you can handle gracefully, like human driving, and what situations, you want to have a redundancy in the system in place where you can, gracefully handle it, pull to the side, or whatever action, as minimizing the risk in a way, right? I think that again becomes extremely important in the whole equation of the system. Cool. All right. So I think, how are we doing on the time? We've got 15 minutes to go. So we have a few questions. We'll get to that. But before going into it, last segment for us to chat, and then let's do the Q&A. I call this to be a crystal ball segment, so kind of predicting the future here. Melinda, what do you think is next here? Like in terms of, the tooling, the workflows, what is going to be the next big step function, for us to evaluate performance quickly, effectively, and accurately?
Yeah, I think I know it's a buzzword, but I do think that Gen AI and generative tools are already, I think, having a big impact on the space. Thinking about being able to generate really large and diverse like simulation sets from kind of a human interpretable kind of prompt and things of that nature are really, really exciting, and being able to kind of know your test coverage in advance, and then generate situations and simulations that kind of match that. I think that's an area that is just really exciting. And I also think it goes beyond kind of the technical work too. I mean, just the impact of these tools on productivity for developers, like using Gen AI tools as a coder, I think is really really exciting. And even within lots of the other roles within any organization, I think is a really exciting area that we're going to see a lot of impact from.
Yeah, definitely. I mean, a lot of buzzwords, but I think these buzzwords are getting turned into reality, as we can see, with OpenAI and DeepSeek and all the great stuff, which is difficult to catch up on all the time, but it's happening for real. Nick, what do you think?
I was going to say, just to expand on that. I mean, I think she's spot on, but I think one thing to expand upon is basically using Gen AI and those tools to kind of accelerate some of the work that we're already doing. I mean, these aren't groundbreaking approaches, but I mean, if you look at performance evaluation across non-autonomy sectors, like whether it's your iPhone or Samsung phone, or any other sort of technology that has a product out there, a lot of those teams focus on how you can quickly dedupe, how you can quickly cluster events, how you can go find events before they're reported. And so I think some of the Gen AI stuff and some of that predictive analysis can really help to accelerate some of that stuff that many of us are probably already doing to some regard. But I would love for my team to not have to look at the same issue over and over and over again. And so how can we really sort of cluster and sort of bulk update these, get these grouped and over to the development teams as soon as possible. So I think that's certainly one thing that I think a lot for my group. Also, I guess just to quickly mention is I think in the autonomy space, many groups ultimately have vehicle operators, testers in the vehicles, right? And they're one piece of way that we get feedback. And I think more and more we're going to need to produce signals to get that feedback without humans in them, right? We're already doing that on the simulated environment. Hey, we've seen some failure here. Hey, you need to look into this sort of thing. More and more, we need to push that onto our actual product once we launch that too, because even though we're launching it, there's going to be subtle things that we need to continue to clean up. These might not be safety critical things, but as I mentioned earlier in the talk, some of our key partners, logistics companies, they have a reputation to uphold. They don't want people calling them and saying, hey, your truck is lane changing back and forth on the highway or turn signal flickering. And so some of these things are more reputational, and being able to extract those things as it's playing out is going to be critical to continue to refine.
Yeah, and I think the reputation, to your point, right, is a very important tenet of this whole ecosystem, because the transparency with the general public who is not as much deep in the technology. And I mean, if you are driving and you have no idea what this truck is, right, even before you can see the tractor of the semi, right, that has all the sensors and whatnot, you're like, hey, this is lane changing very abruptly, what's going on, right? And then I might get in touch with DHL, FedEx, or whichever company, and that could be a PR optics issue, right? So I think it's very important to kind of communicate the intent of the vehicle and the platform with the general public as well as sharing your product technology with the audience. Awesome. We can keep chatting on this, for a very long time, and I want to make sure we are able to get through some questions, as many as we can. So I'm gonna, not in any particular order, take the first one. There seems to be a fellow from Michigan along with me. So our assumptions made on the road conditions in Michigan potholes pop up after winter. The gist of the question is, how do we differentiate between a map that is released before and a new map, right? I mean, changes happen pretty dynamically. Can we detect such changes, on board, or do we have to release a whole new, kind of map to handle this? So while I've directly managed mapping teams, so I'm not going to take this. I'll first have Nick. Do you want to go on this, because you had mapping as one of your portfolios before?
Yeah, that's right. Yeah, This is a challenging one, I think. However, internally, we I think whether it's potholes or in particular construction zones are probably the key thing, where you build a map, you deploy it to the vehicle, and then all of a sudden they've shifted lanes to the left or completely in a different direction. And so I think you do have to have a sensor that, or I mean, a system with sensors, of course, that recognizes that and sort of alters the map in real time. And so I think, yeah, I mean, we have this type of technology that sees that, hey, there's Jersey barriers or there's cones, there's pylons that have shifted the lanes, and on the fly, allowing our vehicle to navigate through there. In certain situations, if it's completely out of our operational domain, we might say, well, we're not going to allow the vehicle to navigate through there. So that's where, having these off nominal detectors allowing us to avoid these pull over for the time being until we are able to develop those capabilities, I think is key. I mean, I will say that, I don't want to say for sure about like potholes. I certainly know our sensors detect them. That's not necessarily a part of the map, though, at least at Aurora. I mean, that's just something that our sensor system is going to have to detect and then allow our behavioral system to deal with.
Right. I mean, there are different layers in the map, right? There are static and dynamic layers. You can adjust for those situations in the dynamic layer. And I think at the end of the day, if you're not able to handle a situation, you, again, as we said before, take a graceful exit and either reroute the system, to go somewhere else, or kind of pull over and have your, field ops kind of take care of it. So there are different ways in which we do it. Also depends on if it's a commercial trip per se versus a testing. Testing can, have a different acceptance trigger compared to when you actually have a product out, commercially operating. Good question. Let's move on to some of the other ones. Melinda, maybe you can take this one up. So we have talked a lot about engineers using simulations to collect data. Do you conduct any HRI testing in simulation with customers? Seems safer than testing a model or product in the real world while still getting user feedback. So I believe HRI probably means human resource or human interaction, UX UI testing. In simulation. Yeah.
I'm actually not familiar with the term, the HRI acronym, but I can certainly address the types of testing that we do, simulations to conduct data. Yes, that's 100%. And I think when I was talking about, shifting testing to the left, that's exactly right, because it is much, much safer and easier and cheaper in a lot of ways to collect data offline, meaning in simulation, with or without hardware in the loop, than it is to go drive either in a closed course or on public roads. And so there's just, I think, only upsides to doing more simulation. And certainly that's where I think, I know Nick has talked about this too, where a lot of the data that we use for testing is coming from, both for kind of day-to-day development testing. So myself as a development engineer, I use simulation, a lot to test my features before even thinking about doing on-road testing, but then also at kind of a overall software release cycle testing as well. So thinking about how are we just, testing all the different pieces of software coming together, the integration testing, and then of course, when we're thinking about acceptance and release testing, simulation is a huge part of that as well.
Right. No, well said. I mean, specifically also about the user experience research testing, there are teams within organizations who conduct, UXR UI testing, where you have the product, you sort of emulate the workflow of, for example, if you're ride sharing like a robotaxi, then you kind of do it using the app. You call the vehicle, you have the vehicle stop, you get in, you do all the the sort of ConOps checks, and then you're ready to go. And then you kind of have the trip status, and then kind of end it. So there are a whole bunch of different, if not simulation in terms of digital simulation, there are emulation workflows which will help us to understand the the whole end-to-end product workflow. And there's a lot of work that happens naturally as a part of your commercial model development. Awesome. So next one that we would take is on traceability. So for complex system, traceability is always an issue. Are there any best practices that can be shared on this one? Nick, do you want to take the traceability question? Maybe the matrix that we can use between. Yeah.
Sure. Let's see. I think on traceability, I mean, I absolutely think that I mean, that's critical to get right. I think maybe I'll just speak to some of the challenges that we faced over time. I mean, and to start, but I think because we've been talking so much about the iterative process of this, where we're constantly learning and making adjustments. And I think for, the taxonomies or hierarchies that we are using in order to add metadata to the analysis that we're doing, over time we start to change some of those frameworks for the better, right? And I think the traceability of those changes is incredibly important. And we run into some obstacles in the past where even just a simple name change, like maybe safety says or legal says, hey, we prefer if you use this other terminology, and we make a simple name change, that can actually have a huge impact later on as people are starting to try to pull in data and look at trends and insights over, from the past. And so it's vital that you have sort of that change management and mapping over time. One way to do that is potentially using some kind of unique IDs that are sort of durable over time. Even if you're changing certain language and whatnot, you've got some durability so that you can pull data and still have access to what has changed. But yeah, I will admit that it's a crucial call out on your part, and it is a very difficult problem to face, and it's a really important one to tackle, though.
Right. I think the evidence of that all the way goes into your final, safety case where you, kind of show the test coverage, your, testing traceability matrix from your, requirements to the testing and output and so on. So just a quick check on the time. We've got a couple of minutes to go. So I'll probably take one last question and then we can, take a wrap here. There are a couple of questions around a similar theme, so I'm not going to pick one specific question as such. But Melinda, what about the sort of redundancy in the system, right? When it comes to handling certain, of course, you have autonomy to be your, the sort of champion of everything. Can you talk about the different layers of redundancies we can build from autonomy all the way down to your on-the-ground operations, and how, what's your view on that?
No, I think that is redundancy is the thing we're trying to build. I think this is a common analogy or model for kind of thinking about risk management, but kind of the Swiss cheese model, right? Where any single thing that you're trying to do to manage risk has holes, just like Swiss cheese. But if you stack enough layers of the Swiss cheese together, you build kind of a solid piece that doesn't altogether does not have holes. So I think of it exactly, redundancy is exactly what we're trying to do there. And it starts really at the autonomy level. Of course, we have at Motional, certainly we don't just rely on one single sensing unit, both in modality and sensor itself. So instead of just using a single camera, right, we have surround cameras, we have 7 cameras or however many cameras we have, LiDAR, radar, we kind of have redundancy in that aspect. And then that kind of translates, of course, to our online decision making, having redundancy in there that we're not going to miss a detection because they're different sensing modalities. Right. But then, of course, kind of in our overall operations too, I think there's a lot of redundancies built in intentionally to protect against this. And I think one of them, is actually, we've talked about this, but the whole test process. There are at Motional, and I'm sure hopefully all autonomous vehicle companies, pretty strict policies on what's the process to actually get code running on a vehicle, and it includes mandatory checks of simulations have been done and hardware in the loop has been done, and checklists of processes that are designed with redundancy in mind to keep everyone safe and to ensure that we're doing the best thing. So I think redundancies are built in, like you said, from ground up, really.
Right. That makes sense. I mean, all the way from your own autonomy platform redundancies to your forward collision warning, AAB, sort of systems which exist on your fundamental base platform. They all contribute to a sort of a acylification per se, right, of your whole product. Good stuff. We can keep chatting more. We can keep having this more in-depth discussion, but I want to be respectful of everyone's time here. So we're just on the clock. And I want to say, a very detailed thank you to both Melinda as well as Nick. Thank you for being here, for participating in this, and following discussion. And I'm sure we'll cover more topics. Some sort of this combination of team will come back again on the Fireside Chat series. Any closing comments, Melinda, with you first and Nick, and then we'll wrap it up.
Yeah, absolutely. Just a big thank you to Sahil and the whole Digital Divide team. This was really fun, and I hope informative for the audience as well.
Yeah, likewise. Yeah, you summed it up nicely. I appreciate everybody here, and I look forward to attending and listening in to future talks for sure.
Absolutely.
Good stuff. So the next talk we're going to have is going to be about simulations and how do we use, how do we take the most out of simulations, which is some sort of a segue from this discussion into, development of autonomous vehicles. So more to come. And Preeti, anything else before we wrap up?
No, just want to thank the team for joining in and giving us such good insights about the performance evaluation. And yes, we'll look forward for more such sessions.
Awesome. Well, spread the word. If you have your friends, colleagues, other people who want to join for these future chats, keep watching on LinkedIn. And again, a big thank you, Nick, Melinda, Preeti, for organizing. Have a good one.
Thank you.